let's see question part B. You have 5 tangent x minus secant x over 6. So now let's differentiate this. So your f prime x is equal to 5. Just rewrite back. We want to differentiate for tangent. So let's see here. The derivative of tangent is secant squared x. So just cut and paste it here. And then minus 1 over 6 as your constant. Minus 1 over 6. And let's differentiate secant. Differentiate for secant is secant x tangent x. So now we have finished differentiating. And please take note that for this one, secant squared x, this is equal to secant x squared. So now let us finalize our answer. So let's factorize the common term. For the first term, we have secant x. Second term, we also have secant x. So let's take out, factorize it. So inside the bracket, you are left with 5 secant x minus 1 over 6 tangent x. This is your final answer. Now let's see example 2. Find the gradient of the curve y equal to 2 sine x minus x squared at the value of x is negative pi. So let's do this. First of all, to find the gradient, we need to find the derivative for y. So dy over dx is equal to 2, just rewrite back, differentiate for sine. Differentiate sine is cos x, minus, and let's differentiate x squared. This is just 2x. So now we have finished differentiating our y. So this is the value of dy over dx. Next, we need to fill in at the value of x is negative pi. What is the answer? So dy over dx, when your x is equal to negative pi, whenever you see x, let's substitute with negative pi. So you will have 2 cos negative pi minus 2 minus pi. So what is cos negative pi? Let's go back to math 1. This is an even function. Cos negative x is just equal to cos x. So now let's rewrite. Cos negative pi is just equal to cos pi. And let's further find out what is cos pi. Cos 180 degree is just negative 1. So now let's rewrite our answer. This is negative 2 plus 2 pi. And let us factorize the common term 2. So inside the bracket, you are left with pi minus 1. Therefore, this is your final answer, the gradient of the curve at the point x equal to negative pi. Next, let's see example 4. Find the double differentiate for y equal to cosecant x. So how should you do this? First of all, let's find dy over dx first. So the derivative for cosecant x, let's see here, this is equal to negative cosecant x cotangent x. So let us simplify, take out negative. So inside the bracket is just cosecant x times cotangent x. Now let's find the higher derivative, the second derivative, d squared y over dx squared. Therefore, we need to further differentiate this function here. This is two functions multiplied to each other. So if you want to differentiate this, you need to use product rule. So how should you do product rule? First of all, identify the first term as your u, the second term as your v. So let's find our u is cosecant x, our v is cotangent x. Therefore, let's find u prime. So differentiate for cosecant is negative cosecant x cotangent x. Just rewrite this here. And for v prime, let's differentiate cotangent x. Differentiate cotangent x is equal to negative cosecant squared x. So let's write it here. So now since you have u, v, u prime and v prime, we can do the product rule now. So the formula for product rule is u v prime minus v u prime. So let's rewrite it here. D squared y over dx squared is, don't forget you have negative outside. So inside the bracket is just the product rule. So let's rewrite u v prime plus v u prime. Next, let us simplify our answer. The negative outside here, let's multiply it inside, so it will become plus. So now you have cosecant cube x plus cosecant x cotangent squared x. Since you have these two terms here, let us factorize the common term. So the common term between these two is just cosecant x. Therefore, for the first function, you are left with cosecant squared x plus, for the second function, you are left with cotangent squared x. Therefore, this is your answer for second derivative.